State the formula that defines electrical capacity. So what's the formula that has the C in it? Q equals CV, so therefore C equals Q over V, 1 mark. Yep. Right, now, if you look here, 2 capacitors, A and B, 20 and 12, are connected to a 30-volt battery and then disconnected. Okay. Calculate the charge in A, calculate the charge in B. What is the total capacity when the 2 capacitors are connected in parallel? Okay, so calculate the charge stored on A. So that's Q equals CV. Right, okay, so let's go straight into the calculations. Q equals, come on, 20 times 30. 20 times 30 times 10 to the minus 6. And then the other Q will be 12 times 30 times 10 to the minus 6. So that would be 600 microcoulombs. 360 microcoulombs. So that's part A and part B done, maybe? Yep, that's A and B done. A, B, C now. Okay. What is the total capacity when the 2 capacitors are connected in parallel? So if they're in parallel, they're like this. There's one up here, and there's one down here. So what's the total capacity here going to be? 20 plus 12. So that's 32 microfarads. Yep. Okay. Now here's the difficult one. The 2 charge capacitors are then connected in parallel, so the negative terminal of A is connected to the positive of B, as shown in the diagram. Electrons flow in the direction shown on the diagram until the voltage of the 2 capacitors are equal. Find the value of this final voltage. So they take the 2 capacitors, they're fully charged, they flip one of them around and connect them together like this. And they want to know what's going to happen, basically. So
we did question like this before.
We did like it, yeah. Okay, so here are the electrons here, and they're moving around, and they'll hit this and they cancel some of the charge that's built up. So I think all that's going to be left is 8 microfarads, I think, yeah?
In the more charged one.
In the more charged one. Yeah, what'll happen is this will be 0 then,
Yeah.
leaving here 8. We believe. We shall see. So we think it becomes like this. Oh, sorry. This here will be 8, and this here will be 0. But then, if you think about it, this is not balanced, so then they have to rebalance back to 4 and 4. So it's going to be like this. And it starts off as 20 and 12. Okay, so it becomes this and then becomes this. So what's the question? Electrons flow in the direction shown on the diagram until the voltage of the 2 capacitors are equal. So that's until they're balanced.
Which is weird.
Find the value of this final voltage. Now that's confusing me a great deal.
Final voltage.
Yeah, final voltage, not final
Are we
current.
talking about the second situation or the third situation?
Well, that's final.
Okay,
Yes. So we want the voltage here. So let's see, what can we say? V equals I or, but there's no or. All right, it's marking scheme time. So how did this question start? There's a picture, okay. I'm looking for a picture. Oh. No. No, I think I should start back here because I'm near the end. No, too far. Too far. Okay, go back to this one. No, I think that's too far. Sorry, I'll go to this one. No. No. No, okay, maybe this one. Oh, yes. All right, let's have a look here. Version 2. 8. $600 and 360. Is that okay? And then 32. All right. When the charges meet, they cancel. Total charge remaining. Oh. Okay. All right. Hang on. I think this is the capacity, not the charge. We added the wrong numbers. So firstly, let's change these numbers. So how much was in the top one? 600 microcoulombs, and here was 360 microcoulombs. That was silly. Okay. All right. So this one here would become 600 minus 360. So that would be a 0 and a 240 microcoulombs. So here would be 120 microcoulombs and 120 microcoulombs. That's the charge, not the capacity. Right. 240. Is that what we got?
Yeah.
120 and 120.
So what's that last bit?
Yes, let me tell you
Let's
about this.
define the voltage.
Yeah, I was wondering. I had a feeling that it wasn't actually this one. So if you look here, in this diagram, this one here, there's not. I prefer to think about it going from here to here. So you have, this is like a battery, and the battery runs a current around. So you know when you have a current moving, you have a voltage. So going from here to here, it's like something like this, where you have a battery going around like that. So there isn't really any voltage here because they're balanced. So there's no movement, right? So actually it's this picture to this picture is what we're looking at. We have this formula, C equals QV. No. Yes. Q. No, don't confuse me. Q equals CV. So V equals Q over C, which is 240 over.
Equals.
Yeah.
Oh yeah, 240 over.
And now, if you look here, they use 32, which is the total here. That's why they ask you to calculate it previously. So that would be 32 times 10 to the minus 6, which would end up being 7.5. Volts. It's a little bit tricky, but now that you've seen it, I think it's okay. So you know this formula here, this is to work out how much charge is in a capacitor when you run a voltage through it. Yes? You got that? But actually when the capacitor is discharging, it produces a voltage, and you can actually work it out from this formula also. So you can use this one here for when it's charging up or when it's discharging to work out the voltage you need or the voltage you make. Yeah? Is that okay, Sayan? I think it's might be the problem here. Oh, sorry.
That should cancel out already.
Yeah, that 240 is micro as well. It cancels out, yeah. Yeah, there you go. Thanks for checking. Okay. That one was number 14. I'm going to, if you look here guys, I'm going to upload this book onto Moodle as well. So let me just show you Moodle before we go.
Oh, with the Mach scheme as well?
No, because to be honest